All right, in this problem, it's a bug problem. The bug is traveling along this line. So before we do anything, well, let's just go ahead and graph this line. Two different ways we can go about doing this. One is I can solve for y to get a y equals mx plus b equation. So let's see, I'm going to subtract 12x from each side. That leaves me with 5y equals negative 12x plus 60. Now divide by 5 on each side, and we get y equals negative 12/5 x plus 12. So the y-intercept is 12, and the slope is negative 12/5. The other way we could do this is we could find the two intercepts. So to find the x-intercept, we just go 12x plus 5 and replace y with 0. And that gives us 12x equals 60 and x equals 5. And one second, bud. To find the y-intercept, go over here. Y-intercept. We just replace the x with 0. And so this term just goes away. 5y equals 60 and y equals 12, which we had from up here anyway. So, and then we just plot these 2 points and connect them with a line, or we could plot this point and use this slope to find the second point. So let's go ahead and plot that line on the y-axis. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 5, 1, 2, 3, 4, 5. Let's go ahead and draw our line. Alright, and it looks something like this. Okay, well there's our line. Now let's take a look at these questions. Alright, okay. We're told, let's see, that the bug crosses the x-axis at t equals 0. It's traveling at 13, let's see, 13 units per second. And we're asked, let's see, when does it cross the y-axis up here? All right, well, if you look here, this is 5, and that's 12, and using Pythagorean theorem, we've got that a squared plus b squared is c squared, 12 squared and 5 squared is c squared, 144 and 25 is c squared, 169 is c squared, and the square root of 169 is 13. Okay. So if the bug is here at time 0, and later on it crosses the y-axis up here, that means it's traveling in this direction, and this is 13 units, and if it's traveling 13 units per second, it must be here at 1 second. All right, and then we're asked to figure out where the bug is at t equal to 2 and negative 1. So we're going to write an equation for this. So let's take a look. Let's set up a table. T, x, and y. Okay. And at time equal to 0, we're at the point 5, 0. And at time equal to 1, we're at the point 0, 12. So between these two, let's look at our x equation first. We go down 5 for plus 1. So our rate of change of x with respect to t is that x goes down 5 for every 1 unit we go forward. And so our x equation starts with negative 5t. And we have to include our starting point here, so plus 5. Y, our rate of change of y with respect to t is 12 units up for every 1 unit of time we move forward. So y is 12t, and then we're starting at 0 for y, so it just stays at 12t. So now we can fill in other points. So let's see, we've got for t equals 2. I mean, we can figure this out. 5, 0 is going to be negative 5 and 24, just following the pattern, but then we can plug these in. So x equals negative 5. We're going to plug in 2 for time, plus 5. X equals, that's going to be negative 10 plus 5. X equals negative 5. Y equals 12 times 2. Y equals 24. So using our formulas, we can get the same numbers we would get by just kind of following the pattern. Let's see, we're going to find where is the bug at t equals 1.5. Probably should have left some room here. 1.5. So let's just plug those in. X equals negative 5 times 1.5 plus 5. X equals, I don't feel like doing all this in my head, so I'm just going to pull up a calculator. Oh, clear. We've got negative 5 times 1.5 plus 5 gives us negative 2.5. And y equals 12 times 1.5. Well, I can do that in my head. That's 18. So at 1.5, the bug is at negative 2.5 and 18, which makes sense. So we're halfway between, so 1.5 is halfway between 1 and 2, and it's halfway, the x-coordinate is halfway between 0 and negative 5, and the y-coordinate is halfway between 12 and 24, so that works. What about negative 1? So I want to put like a squiggly line in our table here. Those are kind of changing things up a little bit. So let's go way over here. Oh, okay. Let's see here. Negative 1. So x equals negative 5 times negative 1 plus 5. So x equals negative 5, that's positive 5, plus 5. Oh, this is 10, sorry. Whew. And then y equals 12 times negative 1, so y is negative 12. So we're at the point 10, negative 12. 10, negative 12. Well, what you think about it, if at 0, we were right here, at negative 1, we must have been further back someplace. In fact, we'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5 would be way down here on the edge of the paper. Can't even see it way down here. Just follow the line on down. All right, I think that answers everything for this one.